Okay, so if you want to challenge yourself with just a crazy pedigree, you could try to read the the script here. And this is a video. If you want to like go to YouTube, you could Google this. I think song is where I got it from, and you can listen to it if you want to. It's just goofy. See if you can build the pedigree. But I'll just challenge you with it. I'm not going to go over it in the video because it's not really like you're going to have to see that on an AP test or anything. But these are the types of questions you might see. For instance, just one example. And so now that we've learned about, Gregor Mendel's P plant traits, which would be passed on through dominance, recessiveness, and we've also learned about X-linked recessive traits, I want to just talk about how to identify whether a pedigree that you're looking at might be one or the other of these. Okay, so just a couple of things to think about. I gave you 3 choices here. I want you to just decide if the pedigrees that are being shown are one of these 3. To your best knowledge, what's your best guess for those? Because sometimes you can't really tell for sure, but you can say, oh, it's probably this one or that one or that one. So just some keys to look for. I'll talk about this first. If the trait is being passed on the X chromosome, remember that one of the things we saw in the top of this worksheet is that it's much more likely that males have the trait, right? And females would only have the trait if they had 2 copies of the allele, like for color blindness, which is rare. It's possible, but it's rare. So males are much more likely to have the trait being shown. Also, another thing to think about is that if the trait is recessive, that means you have to have both recessive alleles to have the trait. Like, for instance, P plants, tall or short. If we're talking about the recessive trait, the P plant would have to be lowercase t, lowercase t. And the thing is that it can get covered up quite easily by the dominant allele, right? So for the recessive trait to be shown, it needs both copies. And so what happens occasionally is that it'll skip a generation. So if you're looking at a pedigree where the trait skips generations, it's very likely it's recessive. Now, you can have a recessive inheritance pattern that doesn't skip generations, so it's not like something you will always see. But if you see a generation being skipped, it's recessive. The dominant trait is not going to skip generations. And again, just like autosomal, the key word there is that it's not a gender chromosome. So it's going to be on, like for humans, one of the chromosomes numbered 1 to 22. Has nothing to do with whether someone is male or female. Okay, so let's kind of take those clues and consider the first pedigree. I notice 2 things right off the bat. I notice that it skips a generation. The trait is not shown in the parent generation or grandparent generation, whatever you're going to call that one. And I know that looking at it, I've got 3 individuals affected and they all happen to be male. So this is most likely X-linked recessive. Most likely. And number 13. Okay, I don't see any generations being skipped, but that doesn't mean it's not recessive, but I don't see that. And I also see an equal distribution of male and female. So even though it could be autosomal recessive, possibly just based on that, I'm just going to say that it's most likely autosomal dominant. Okay, this one skips a generation, and it is an equal distribution of male and female. And like, it can't be on the X chromosome. If this were like color blindness and that person, this female, had color blindness and she hadn't had sons, the sons would be colorblind. They would have the trait because she's going to pass. That's how it works. If it's X-linked recessive, the sons get the trait from the mother. Anyway, this one has to be autosomal, and it has to be recessive because it skipped a generation. 15, no generations being skipped. Most likely autosomal dominant. Okay, so just a couple things to think about there. Hope this went well.